The following work, entitled Photocatalytic Degradation of Naproxen Sodium using visible light and zinc oxide modified by the combustion method. It is presented by Jacqueline Leslie Valdez Guerra et al. Presence of pharmaceuticals in water bodies cause environmental problems and health problems. So it is crucial to remove these pharmaceuticals from water bodies. Thus, in this work, we present the photocatalytic degradation of sodium naproxen using the ZnO photocatalysts obtained by the combustion method and using urea as fuel. These three zinc oxides with different urea molar radius were synthesized. These photocatalysis were characterized by the different methods present, and the materials were evaluated by the gradation of sodium naproxen using visible light, approximately 390 nanometers. Later, I will explain the results of the characterization and evaluation. We showed that the use of urea during the synthesis process led to important changes in crystal size, band gap, energy, and morphology. The improvement of the photocatalytic activity is possible due to the formation of structural defects caused by the use of urea during the synthesis process. An introduction where have that emerging pollutants are composed of different origins and chemical nature, have high toxicity, causing serious damage to flora and fauna. There is wide range of emerging contaminants, including pharmaceuticals, that are not included in the current monitoring of water treatment programs. In Mexico, most of the country's surface water bodies receive untrained wastewater discharge. So, photocatalysis is one more alternative for water decontamination, since it is possible to degrade pollution organic molecules by means of ultraviolet or visible light. This is how in this work synthesized oxide is used as a photocatalyst for the degradation of naproxen sodium. The synthesis methodology is as follows. For each photocatalyst, nitrate plus urea was added at different molar radius and 3 milliliters of deionized water. Mechanical mixed for 15 minutes, then is what left to drain for 3 minutes and 95 degrees Celsius. Finally, it is calcined at 500 degrees Celsius for 3 hours. The photocatalytic evaluation is carried out in a system like the one presented. In the batch reactor, the polluting solution and the photocatalyzer are added. This is kept under constant agitation and eye bubbling. It has 10-watt LEDs with a wavelength between 300 and 90 nanometers. At was analyzed by ultraviolet visible liquid spectroscopy and total organic carbon. The photocatalysts were characterized by X-ray diffraction, ultraviolet visible diffuse reflectance, scanning electron microscopy, and analysis by ray energy dispersion. Figure 1 shows the X-ray diffractograms and the ultraviolet visible diffuse reflectance spectra of the synthesized materials. The table summarizes the weight at half-height of the diffraction peaks 100 and 101, as well as the average size and background energy of the synthesized material, where is observed that the width at half-height of the diffraction peaks increase when urea is added at the time of the synthesizing, and the rare crystal size decreases as the background energy increases. Figure 2 show the scanning electron microscopy images of the synthesized oxides. The material without urea is made up of the different shapes, including a pyramidal structure. See figure 2AB. On the other hand, the material synthesized with urea are formed mainly by clusters of particles. See figure 2C2F. And table 2 summarizes the elemental composition of the zinc oxide synthesis. The material synthesis with urea have an oxide zinc molar ratio equal to 1 plus minus 0.1, which agrees with the stoichiometry of the zinc oxide compound. The result of energy dispersion spectroscopy indicated a significant carbon content, which increases when higher urea content is used in the synthesis process. The presence of carbon in the analysis samples indicates impurities absorbed in the material, which is common when it is synthesized by the combustion method using a fuel agent. Figure 3A and 3B presents the ultraviolet visible spectra of naproxen sodium liquid during the photocatalytic process using the zinc oxide urea 0 and zinc oxide urea 6 material respectively. Both material present a decrease in the band 100 and 271 nanometers, currently indicating that the sodium naproxen present in the solutions decrease its concentration. Being more notable in the material synthesis with urea, figure 3C shows the relative concentration of the contaminant as a function of the reaction times the photolysis reaction without photocatalysts, and using the synthesized materials. The photolysis reaction did not present significant change in the concentrations of the contaminant, indicating that sodium naproxen is stable when it is irradiated with light with a wavelength of 390 nanometers. When the photocatalysts synthesized with urea are used, the naproxen sodium concentration decreased considerably. Then the materials in oxide urea 6, the one that presents the hates photocatalytic activity. The presence of mineralization of the contaminant after 118 minutes of reaction is present in figure 3D. The synoxide urea 0 material showed a mineralization of 7.5%. The synoxide urea 3 material showed a 22%. And finally, the materials synoxide urea 6 was 66.1%. The increase in the percentage of mineralization is due to the synthesis of synoxide using urea as fuel agent, which could cause structural defects that favor photocatalytic activity. The oxides of the photocatalysts were synthesized by the combustion method using different urea contents as well. The use of urea led the change in crystal size from 63.6 to 31.3 nanometers. Background energy from 3.310 to 3.234 electron volts. And morphology. The synoxide synthesized without urea managed to mineralize 7.5% after 118 minutes of reaction. Will the best material synthesized with urea? Urea syn 2 equals 6 is to 1 molar radius. Managed to mineralize 66.1%. The improvement of the photocatalytic activity could be due to the formation of structural defect caused by the use of urea during the synthesis process, favoring the degradation of the contaminant. These were the reference used. Thank you for your time.